This is chapter 7 summary notes on chemical reactions and quantities. We're still in the part about chemical reactions. We're going to be classifying them as to type. All right, so in our very first picture here, I've already highlighted some magnesium ribbon here that's in pink. You can see it extending out. A flame has been applied to this, so that's why you see this heat symbol here that's also been highlighted. And as this flame occurs, oxygen from the air actually combines with the magnesium to form magnesium oxide, which you see over on the right. And this is called a combination reaction, all right, because two things become one. It's also known as a synthesis reaction, so you might see that term in another textbook. Synthesis means coming together, all right, or combination. Decomposition is kind of the opposite of synthesis or combination because we take one reactant and it breaks down to form several other substances. They could be two elements, or they can be two compounds, or an element and a compound as products. It just depends what the main reactant is. In this case, we have two mercury oxide units in the formula, and it breaks down to mercury, all right, liquid mercury and some gaseous oxygen, all right, but one thing becomes two or more, all right, not just two. Sometimes it could be more than two products. All right, so that's decomposition. It's kind of the opposite of combination. All right, single replacement, you can kind of get a hint of what that means because you're going to see a single element on one side of the equation, and then you'll see a different single element on the other side of the equation. Because the element reactant actually pushes out one of the elements that's in the other reactant, okay, to form a new substance. In this case, zinc is pushing out the hydrogen, and the hydrogen is released as gas, and the zinc combines with the chlorine to form zinc chloride. So one element replaces another, okay, in a single replacement reaction. Sometimes it's a metal replacing another element in its first position or in its metal position. Sometimes it can be a non-metal replacing another non-metal. Let me get that other thing out of the way. All right, now we got it. All right, so that is a single replacement reaction. So now let's see what a double replacement reaction, sometimes these are called displacements. All right, in this case, all right, we have sodium sulfite, and you see the colored spheres here representing the atoms, and we have some barium chloride. And what's interesting here is that the metal ions, the sodium and the barium, literally switch places. The sodium goes with the chlorine, the barium goes with the sulfate. Okay, so on the other side, we have barium sulfate and sodium chloride. So you have two partners on the left, you have two new partners on the, or two, I'm sorry, I'm getting mixed up. You have two elements on the left that switch partners to become two new compounds on the right. And I'm thinking about the double dating situation that sometimes happens at proms or at dances. Two couples go, but two new couples leave, but it's the same four people. All right, but they're just two new groups. All right, so that's kind of what happens in a double replacement reaction. All right, two compounds on the left, two new compounds on the right. So that's a double replacement. The easiest one to see is combustion, because combustion involves carbon, hydrogens, and oxygens. There are other kinds of combustion reactions, but this is a classic type of combustion reaction that I'm showing you here. Don't be intimidated by the subscripts or superscripts that are present. In this case, we have a 23 behind carbon, 48 behind hydrogen. It becomes very easy to balance these if you do them in alphabetical order. All right, so carbons, then hydrogens, then oxygens. All right, so we haven't balanced any of the other equations, but I thought it might be fun to do this one. All right, so you won't get worried if you see something this large. In this case, you have 23 carbons on the left, which is a type of paraffin that you see in the picture over here, burning candle. So we want to put a 23 in front of the carbon dioxide on the right. There's 48 hydrogens on the left. So in order to get 48 back on the right, we cut that in half to make 24. All right, then we can add up the oxygens on the right. So we have 2 times 23 plus 24 tells us how many oxygens are on the right-hand side. We got 46 plus 24. And how many is that? 60, that's 70 oxygens. Oh my goodness. All right, so how do we write 70 oxygens over here? All right, remember we have that subscript of 2 we need to take care of. So we divide the 70 by 2 in order to find that new coefficient. And yes, it will be a 35. All from one molecule of C23H48, which is paraffin. We need 35 oxygens. It gives us 23 molecules of carbon dioxide, 24 molecules of oxygen, of water, excuse me, and then lots of energy as well. All right, so that's a combustion reaction. Here's a summary table of the different reaction types using some general information, general letters on the left to represent the compounds with the substances that are involved. So you can use that as a reference to do the following set that's down here. Remember, combination is 2 becoming 1. 2 becoming 1. Decomposition is 1 becoming 2 or more. Single replacement, you have a single element on the left, a different single element on the right. Double displacement, 2 compounds on the left, 2 compounds on the right. Combustion reaction, recognize your carbons, hydrogens, and oxygens that are there. All right, and sometimes the energy component is listed. All right, so the practice set that's here asks you just to identify in the first set and balance and classify in the second set. So stop a moment and do the first set, check your answers, and then we'll talk about those answers and go on to the second set, similar fashion. All right, so take a look and see, check your answers. This first one is single replacement because we saw a single element on the left, another single element on the right. All right, so the aluminum replaced the hydrogen in the H2SO4. In the second reaction, double replacement, you have 2 compounds on the left, 2 compounds on the right. In the first, the metal ions have swapped places. The silver goes with the sulfate, the sodium went with the nitrate. All right, and the third one, this is a combination reaction because 2 substances, 2 or more substances can make 1, but in this case it's 2 that makes 1. Sometimes you can have even 3 that combine to make 1 product. All right, and the last one is the combustion reaction because you have some C2H4 here, which is acetylene gas, welder's gas, some oxygen, giving you carbon dioxide and water, and lots of energy to do that welding. All right, so the only one that's not shown is the decomposition. All right, so again, stop the video, try balancing this set. All right, there's 4 that are here, and classifying these. All right, then come back and check your answers. Okay, on this second set, take a look at your combination reaction. You need 3 barium and 2 nitrogens to get 2 barium nitride products. All right, and this is a combination, 2 to make 1. Silver, we saw this at the very beginning. Did you remember this equation? 2 silvers plus the hydrogen disulfide, silver sulfide, and hydrogen as a single replacement reaction. I think we saw that in the first video for this chapter. All right, combustion reaction. Notice how I did this. I did my carbons first, 2 carbons, 3 hydrogens because there were 6 on the left. I stayed over here and added up the oxygens, which was 4 plus 3 is 7. All right, so to get the coefficient in front of oxygen on the left, I divided that in half. That gave me my 3.5. But we can't have half a molecule, so I doubled all the coefficients. Just remember to double that implied 1 that's in front of the acetylene that's there. All right, so everything gets doubled, and notice we can't reduce those 2, 7, 4, 6. All right, because 7's a prime number. Anytime you have a prime number, it's not going to reduce any further. All right, and then on the last one, the lead chloride, I forgot to balance that, so let's do that right now. Have K2, Cl2. Guess what? That's all it needs right there. All right, is the 2KCl. And that balances this one. And it's double replacement. Okay, the lead and the potassium swap places. Lead goes with chloride. The lead goes with the sulfate, and the potassium goes with the chloride. All right, so I hope that makes you a little more comfortable on balancing and classifying together, a little bit more practice on balancing, and good luck with your homework on this. Or if you're using this as a review, good luck on your quiz or your test.